use for some unsupervised training or self-training. So this is what we have for the resourceful languages, and we know how to train speech recognizer using such data. And now our problem is, let's have some resource-less language or low-resource language for which we have only the text data for training the language model. Maybe we can download it from Wikipedia or whatever. It will, hopefully it has some written text. And we have some speech, but unrelated to the text, so untranscribed speech, and we would like to train speech recognizer using these resources. So the task here is to eventually learn something from the resourceful languages, learn how can we find some pattern in the text data and corresponding patterns in speech, and how to match these patterns in the text and speech in such a way that we can discover words even in the untranscribed data. So seeing some statistics on text and then looking in the acoustic data and trying to see something that is occurring similar frequently and in the same order also in the acoustic data. So, I mean, the motivation for this work, obviously, we would like to build the speech recognition system, spoken time detection system, whatever speech processing system for language where we have limited or no transcribed data, and where we have no expert linguist who would build us the pronunciation dictionary and say what phonemes we have in the language. And there was recently quite some interest in building such systems. So here are the examples of two projects, one DARPA project, one IARPA project, where the DARPA Lorelei project is about building system that would help in the emergent missions like the humanitarian assistance, disaster relief, peacekeeping missions, and so the task is there to help to process some untranscribed data, possibly for very exotic language for which no resources are available. Similar project. The IARPA Babel project is again about training speech recognizing in a very short time for new coming languages, possibly with limited amount of transcribed data. So there is interest in this problem. The approach that we thought that we would take would be to come with a generative model which describes how the speech is generated from. So generative model is something that people were using for a long time for speech recognition. We actually tried to use similar kind of generative model, but we are different in certain aspects. So the generative model is kind of the standard structure that we assume that there is the language model, which tells us the statistics about what are the probabilities of different word sequences in the given language, and from this language model we can generate a word sequence. Given some lexicon from the word for that word sequence, we can generate sequence of acoustic units, possibly phonemes, but we actually don't know what the acoustic units are going to be. And given the acoustic units and given some acoustic model, we can generate sequence of speech. The problem here is that normally we would be provided with the lexicon, we would have some transcribed data to train the acoustic model, and then we can build the whole system. But here, the only thing that we have is perhaps the language model that we can train on the data. So we have these resources available. The untranscribed speech, we have the text that we can train the language model on. We observed the speech, but we know nothing about this thing. So we need to build the middle part as some Bayesian model with some latent variables, and our task is to actually infer these latent variables. And eventually we can use the transcribed data from other languages and use that as some prior knowledge for learning the latent variables for these submodels for the lexicon and for the acoustic model. So why do we choose generative model? Like recently, everybody started using discriminative model and deep neural networks for speech recognition, but the generative models would be more suitable for this task of unsupervised training. So this is why we went for that one. we eventually make use of some discriminative models, as you will see, for actually to learn from other languages, but the main model was supposed to be the generative one. And the problems that we need to resolve with the model is we actually need to learn how many acoustic units are there in that speech, segment the speech into the acoustic units, so find the timing for the acoustic units, learn the pronunciation of the words that we have in our dictionary. We know what the words are there. Eventually we have the language model, but we don't know what they are pronunciations, and translate the sequences of acoustic units into the sequences of words. And so there would be some latent variables that corresponds to these problems in our model, and these are the latent variables that we need to infer. So what kind of generative model are we going to use here? We actually built on recently proposed Bayesian model. So you will hear today about Dirichlet process infinite mixture model that we use for the acoustic unit discovery, as the acoustic unit discovery model, hierarchical Pitman language model that we use for language modeling or for actually learning the lexicon, some graphemic lexicon learning, nested Pitman language model for automatic word discovery, and so on. So we are built on top of these models, but we try to just put them into single scheme and build the complete generative model of that we can train in the unsupervised way. And what we did during the workshop were eventually some non-trivial extensions of this model, so that we can really use it for the task. We can even apply it to some larger scale problems. So we'll see whether we succeeded or not. So right now it seems that the task is quite difficult, but it seems that it would be doable, and we can get some interesting results with it. Okay, so when I say we have this generative model, then if we want to actually recognize the sequence of words, the inference that we need to run with the generative model is to invert the model. People often talk about inversion, so I describe the generative process. I said how one can generate sequence of words and so on, and finally sequence of frames in the generative process. But what we need to do is actually the opposite thing. We need to start with the speech, and we need to invert the model and infer the latent variables. And here it looks like that, okay, so we get some model that gets speech, and this gives us sequence of acoustic units, and that gives us some sequence of words. But since we deal with Bayesian model, we try to keep take into account the uncertainty and to count with the uncertainty. So it would mean from speech we eventually generate some lattices of acoustic units, and which would tell us something about uncertainty of the acoustic units, and then we apply the next model, and we try to derive from the lattices and from all the possible hypotheses of the acoustic units what possible word sequence could we get, and so on. So you will hear about the actual models later on. For this presentation, we have for the work during the workshop, we have kind of divided the system into two halves. So there would be one half which has this central component would be the automatic unit discovery model, and the other part which is actually trying to learn. So this part of the model would be the one which tries to learn something from the acoustic units. So the acoustic units would be input to the other one. So we divide even the presentation into two halves, where we would first talk about the acoustic unit discovery and about improving the acoustic unit discovery model, and you will learn about the actual acoustic model, how we can benefit from jointly training the acoustic unit discovery with some simple, but not that simple, Bayesian phonotactic language model, how we can learn from other languages. We actually started using the acoustic units to learn better features, and then to use the better features to get better acoustic units. So we will see how we start putting things into loop. We have there will be presentation showing you some alternative ways of evaluating the system. So we were the guys, some of the people at the workshop were trying to use the acoustic units for topic detection task, or the same different word comparison task. So you will see that how the quality of the acoustic unit relates to evaluation on these different tasks. And so this would be the first half of the presentation. In the second half of the presentation, we will start learning more about the actual word recognition model, which uses the acoustic units and how to possibly train it jointly with the acoustic units, and what different variants of the word recognition models we have. I will stop it right here. I will go through these slides and I make the introduction to the second half at the beginning of the second half. And now let me hand the presentation over to Luca, and he will tell us something about the acoustic unit discovery.